Outliers.
You learn that the empirical rule is used to study data points that fall within the bell curve. There are certain data points that don't fit the pattern or the trend of majority of the data though. These odd ones out are called outliers. Let's learn more about the characteristics of the outliers. Just like in a group of friends of similar height, someone extremely tall or short will stand out. Similarly, outliers stand out from the remaining data set. Outliers can be interesting, but they also need special attention to understand why they are different from the rest of the group. Outliers are data points that deviate significantly from the majority of the data in a data set. They are observations that are unusually far away from the central tendency of the data, such as the mean or median. Outliers can arise due to various reasons, including measurement errors, data entry mistakes, or truly extreme events or behaviors. In order to understand the deviation of the individual data point from the mean, you will need the z-score, also known as the standard score. The z-score tells you how far from the mean of average your data lies in a normally distributed sample. The z-score quantifies the number of standard deviations a raw score deviates from the population mean, whether below or above. A positive z-score means that the data point is to the right of the mean, and a negative z-score means it is to the left. For instance, if a data point has a z-score of negative 0.8, it means it's quite close to the mean, just with one standard deviation. It's part of the first 68% group. But if a data point has a z-score above 3.2, it's considered an outlier. It's way out there beyond 3 standard deviations and is not typical of the majority of data points. Here's a simple formula to calculate the z-score. Z-score equals to data point minus mean divided by standard deviation of the sample. Take a look at this test score example, which is a class of 25 students with test scores following a normal distribution, mean of 81.6 and standard deviation of 8.3. We can use the concept of outliers to identify exceptional performances or potential issues with the data. Now, consider 2 scenarios. In the first scenario, student A scored 63 on the test with a z-score of negative 3.7. This means the student's score is 3 standard deviations below the mean, and according to the empirical rule, less than 0.3% of the data is expected to fall in this range. In this case, student A's scores of 63 is an outlier. It is much lower than the average performance and is usually far away from the typical test scores in the class. These low scores might prompt further investigation into possible reasons for the student's poor performance. In the next scenario, student B scored 100 on the test with a z-score of 3.6. This means the student's score is 3 standard deviations above the mean, and again, less than 0.3% of the data is expected to fall in this range. Student B's score of 100 is also an outlier. It is significantly higher than the average performance and stands out as an exceptional result compared to the rest of the class. Outliers can have a significant impact on statistical analysis and interpretations of data. When present in a dataset, they can affect measures like the mean and standard deviation, making them less representative of central tendency and variability of majority of the data. Handling outliers depend on the context and the specific analysis being conducted. In some cases, outliers may be genuine extreme values that need to be considered in the analysis. However, they could also be the result of errors or unusual circumstances that should be treated or removed to avoid skewing the results. In conclusion, outliers are data points that stand apart from the majority of the data and may warrant further examinations to understand their significance and impact on the analysis. In the context of test scores, outliers can indicate exceptional performances or potential issues with data quality that require careful consideration.